Part 2. Where will we end up on the curve? For equilibrium, P down is equal to P up. Down and up is same probability. That means P up is 1 minus P down. So for equilibrium, P down is a half. Since P down is equal to Ps, then for equilibrium, Ps is a half. Yeah, it's a lot of things to. Of course, it is like that. 50%. Yeah. Transformed up down. Simple up down level depends only on previous response. So simple up down, it should be 50%. Transformed up down levels depend on other 2 or more previous responses. Okay. There could be 1 up, 2 down. What does that mean? You increase level after a no. Decrease level after 2 yes in a row. So convergence for 1 up, 2 down. Equilibrium, P down is a half. Okay, but P down is the same as the probability of 2 yes in a row. And so P down is P yes times P yes. Okay, so for equilibrium, P yes squared is a half. Yeah, okay, is a half. That means a P yes is a square root of a half. That is 0.7. Okay, yes. Yes, and for instance, if it is 1 up, 3 downs, then the P yes is the same as a third root of a half. Yes. Okay. Yes. What happened if we? Okay. So we can continue like that. What happened if we use a 1 up, 1 down procedure? Yeah. Okay. Bias. Yes, no experiments. Criteria. Can we avoid bias? Making things a bit more formal from introduction to signal theory. 2 hypotheses, absent and present. Okay. Yes. Observation of measurements is called R. R can be a vector or set of measurements. Based on the observations R, detector selects a hypothesis. What is the probability of H0 if R is happened? And what is the dependence probability of H1 if R is happened? We have some logic. If R is less than so-called criterion, we select H0. Yeah. If R is bigger than criterion, we select H1. Okay. Yes. We have some. Okay. So we have some 4 possibilities outcomes. I will not tell you. An absent H0, a signal absent, and we select if signal is absent and we select H0, so is a correct rejection. It's called a true negative. Yeah. Okay. But if the signal is absent but we select H1, that means that we got a false alarm. Yes, you can sketch in on these figures. If the signal is present, there is a signal, but H0 is selected, then we get a miss negative. If the signal present and the H1 is selected, we get a hit. Yes, true. Yeah. Okay. Yeah. Yes. We got if we receiver, we got now receiver operator characteristic. Consider performance for different criteria. Rock code. So it's so-called receiver operator characteristic. So we get a false alarm on the first axis and hit rate on the second. That means false alarm here and hit on the other one. Yeah, if there is a signal. If there is a signal. False alarm versus hit rate. Yes. So we can get some different rock curves on this. Yeah. From Torsten Paulsen. The ratio between hits and false alarms is used to determine a point on a so-called rock curve. ROC stands for receiver operating characteristic. An example is shown in this figure 4.2. If the test subject's criterion is changed, the point will move to another position. So we have a false alarm rate and a hit rate. False alarm rate, that means that false alarm rate, that means that we have no signal, but H1 is selected, and hit means that we have a signal, but and we also select H1. Yeah. Yes. Okay. False alarm here. Yeah. Yep. Yeah. So we on the other side of the criterion. Yeah. Yeah. Blah blah, and we can use bias rules to get some other probabilities. Yes. Yeah. Yes. Yeah. Okay. Then two alternative force choice 2AFC. Example of two interval alternative force choice presentations. Listener must pick the interval that contains the signal first or last, and then you can also get be extended to more options 3A, 3AFC, 4AFC. Yeah. Multi-dimensional scaling. I will not go into this. So that was part 2.